Hello everyone, welcome to another episode of Embedded Blockchain, where we talk about the latest technology in the Internet of Things, blockchain and self-driving cars. I hope you're doing well. Today I'm going to talk to you about how self-driving cars work. A self-driving car is basically a robot. It works in a very similar way. A robot is capable of sensing the environment around it, is capable of recognizing the objects, making decisions based on those objects. Decisions such as obstacle avoidance, if it needs to avoid an obstacle, if it needs to stop, if it needs to move to the right, to the left. Those types of decisions. In a very broad term, we have a diagram of how the self-driving car works. A self-driving car has lots of sensors. Here we see some of the sensors which are commonly used in the self-driving cars. Radar is one of them, detects the presence, also the speed of objects at which they are approaching. LiDAR, which is extremely accurate, it gives you a 3D representation of all the objects around it. It's a very nice technology that is being used in self-driving cars. And of course, camera, computer vision, it gives you all a clean picture of the objects, and you can manipulate those pictures by doing color filtering, object detection, and all those things. Now, since we have several sensors, those sensors can give us different data. I mean, the data can differ among the sensors. So we need to merge the data, and that's why we have here a sensor fusion. That's what it does. It merges the data from all the sensors, and it gives us an accurate representation of what's going on around the self-driving car. Another stage is localization. Here, basically, the car needs to know where it is. One of the common technologies is GPS, like the one you use on your phone. This is used to localize the vehicle. It needs to know where it is in order to make a plan. The car needs to know where to go, where it is, and make a plan, a path in order to drive. And the next stage is precisely path planning. Once you know where you are, once you know what your environment is, then you can plan your path. And lastly, control. Once you have all the plan, you have all your environment, now you need to drive. You do that by applying control. Here we have a very nice representation, very nice explanation of how self-driving cars work. Here we see the most common sensors in a self-driving car. We see A, for example, is LiDAR, builds 3D representations of the environment by reflecting lasers. That's basically a laser beam, and the laser beam bounces off the objects, bounces back to the sensor, giving you this clear or at least a 3D nice representation of the environment. And then we have cameras. Well, we all know cameras gives us images, color images, that we can use to manipulate. We can manipulate the data in the images and detect the objects in that image. Radar, which uses radio waves, it also sends radio waves to the object. They bounce back to the sensor, and it can give you an accurate measurement of the distance and the speed of the object. Another one is GPS, which is used for localization. The car needs to know where it is in the road in order to plan for the driving. Another one is ultrasonic sensors. This one is used for nearby objects. It is very useful when parking. For example, when doing autonomous parking, ultrasonic sensors are very useful because they can help us avoid hitting the other car when you are parking. Unlike radars, which are long, they are used for long distances when you're driving on the road. Ultrasonics are not useful when driving on the road when we need a long distance detection. Radars are more useful in that case. One of the first stages here is the map building localization. Once we have all the data from the sensors, as we explained here, we have a sensor fusion. We merged all the data from all the sensors. We can actually build this map of all the environments surrounding the vehicle, and we can also have a localization where it is. Once we know where we are, once we know what's the environment, where we can go and all those things, we can make a decision. We can plan our road, and here we have path planning. Once we know where we are, we can plan. For example, there's an object, there's a car in front of us, so we can go to the left. The car can go to the left. That's a path planning. Obstacle avoidance also, because if it goes straight, it will hit the car. So you need to go to the left in order to avoid hitting that car. This is in broad terms how self-driving cars work. When it comes to path planning, the tasks are a lot more complicated than they seem. Self-driving car software uses a lot of algorithms, complex algorithms, such as machine learning, neural networks, in order to predict what's the next move. If a car is approaching to us, what's the next move? We need to change the lane. Do we need to turn right, left? Do we need to stop? All those decisions become very difficult once we are driving on the road. So we need decision-making algorithms. For this, machine learning is very useful. Machine learning is being used broadly nowadays in the self-driving car industry. Here we have some of the issues also. Some of the issues self-driving cars are facing. Combination of all these technologies, hardware and machine learning software, it's very difficult, since the behavior of the other objects is very unpredictable. We don't know, we cannot predict what the other object is going to do. If it's a person, or if it's another car, if it's an animal that's in front of us, we don't know what it will do. So trying to predict the behavior, trying to make a decision based on that behavior becomes very, very complex. So the complexity in the perception, also in the decisions, and also in the perception, it's what is holding all this self-driving car industry back. Perception is one of the most difficult parts, since weather, all these weather conditions can affect the perceptions, such as snow, fog, and many things that are becoming very, very difficult in the self-driving car industry. Another one is security. If all these object detection and decision making is not very clear yet, then we don't have security yet. We cannot assure that the self-driving car is gonna drive safely, is gonna prevent accidents on the road. We cannot assure this yet in the self-driving car industry. This is what is becoming very difficult. Well, that's all. Hope this video helps. Thank you. Bye bye.